Hi there, my name is Robert Puryear, and I'm the Chief Scientific Officer for MTAC USA. We are an HPLC column company, and today I want to talk to you about an amazing column. It's been out about 10 years now. It's called the Intrada Amino Acid. This is a mixed mode that combines normal phase helic mode plus ion exchange, and it can do some really fantastic things, least of which is that it allows you to analyze amino acids without the need for any derivatization. So let's get into it.
All right, so let's talk about the Intrada Amino Acid column. This is such a special product. It's been out now for about 10 years. I remember the day that Yazawa first introduced this column to me, and I just couldn't believe what he had made. So let me first introduce you. This is Yazawa-san, Mr. Itao Yazawa. He founded MTAC in 2000, so we've been around for over 20 years. And his background, he started as an analytical chemist, where he said he was really frustrated with the types of columns that were available at that time. And that really led to his passion to want to create stationary phases, which is what he did at YMC. So if you've ever used the YMC column, you're probably using his stuff already. Then he worked at Shimadzu, actually on the equipment side. So he likes to say that he understands chromatography from all sides. But again, when he was at YMC, very limited type of stationary phases that he could develop there. And so that's why he started MTAC. Basically, to make all the columns that he wanted to make without any restrictions. And that's really a driving philosophy of our company, is to make the tools that chromatographers need and can't get. And Intrada Amino Acid is definitely an example of one of those. Here are all of our columns that we make. We're always adding new, so this is subject to change, but there's quite a few world firsts on here. And if you ever want to know, walk through some of these solutions we have, please hit me up. Be happy to go through that with you. This is a column selectivity chart. It makes it easy to kind of narrow in on the type of column that you're interested in. For this example, since we're talking amino acids, that's going to be small molecule, polar, and then we're in the multi-mode branch. And here you can see we've got quite a few. In fact, I believe, I feel we're the industry leader in multi-mode columns, and Intrada Amino Acid is an example of that. And it's right here on this chart. And basically what this is a helic column, so normal phase, plus ion exchange. So that's the mixed mode part there, since we have two separate types of ligands going into this, and it works amazingly well for separation of amino acids. So let's talk about why I was so amazed when Yazawa first told me about this column. And that's because, I've been in chromatography my entire career, and every time somebody asked me about an amino acid analysis that they were doing, I got a little bit of a cringe just because there just weren't any good options. I mean, if they were doing amino acids, I just knew it was going to be, there wasn't ever really a home run solution that I could offer them. That's because, primarily, historically, these methods have relied on derivatization. I think the most popular is the OPA method. There's also a ninhydrin post-column derivatization. Phenomenix has the Easy Fast kit. I think there's AccuTag. So there's quite a few solutions out there, but before the Intrada Amino Acid, most of what I've seen has relied on some type of derivatization. And there's even a few of these Hitachi amino acid analyzers running around, which is a big equipment that sits in your lab, takes up a lot of space, uses a specialty column you have to get directly from Hitachi. Mobile phase you have to get directly from Hitachi. So yeah, not a good solution. What makes this column special is that it doesn't require any derivatization at all. When I heard that, I was just like, what? Are you serious? So let's get into how this works, and it really is quite a fantastic product. Here's one I like to show to start with, just because it's like a tour de force. We've got 55 amino acids. Guaranteed, if you're working with an amino acid, it's on this slide. So the key to making this work without derivatization is, first of all, you need to use mass spec for your detection. Just because amino acids are not chromophores, so they're not going to be able to be picked up on a UV without that. But even with mass spec, there's a limitation because, for isobaric compounds which have the same mass charge ratio, you need to have chromatographic resolution. And that's what I'm showed circled here is, the leucine isomers at the bottom, the GABA isomers up top, and you can see we have chromatographic resolution for those isomers. So not only does it separate very well amino acids, but it can even get at those isomer products. All right, so I want to show this just to highlight that, in the 10 years that this column has been out, we have a ton of app notes on our website. So if you have an interest, please go to our website and search up app notes for this column, or even better, send me an email at info@mtechusa.com, and I'd be happy to point you in the right direction. I do like this app note because, first of all, it's from a customer, not one of our own. That always has a little bit more weight to it. But it also shows the precursor and product ions. So this is a MSMS separation. So this is a really nice reference if you're working with MSMS and you're doing amino acid analysis. Here's another one, just to show it's working on another system. This is a more simple mass spec, so it does work on single quads. Not a problem with this column. So don't feel like you need to get into a very expensive machine to be able to do this. So that's another app note. This one, what I'm highlighting here is, in the 10 years that I've been working with this, we get some of the same kind of troubleshooting with this column. And so I want to hedge that off by explaining how to properly use this column. The first thing to address is because this can catastrophically fail your column, and that is the protein precipitation of your sample. As I said before, this is a normal phase plus ion exchange mixed mode. So in normal phase, it's a reverse phase, right? We're going to start with high organic mobile phases. So if you have any protein in your sample, it's going to crash those proteins out immediately. And then those denatured proteins are going to be permanently lodged on your column, and there's no washing that's going to undenature those and get them off the column. So the only solution at that point would be to buy a new one. So we want to avoid that. So make sure that you do a very good protein precipitation. Now, I want to just state a few things about protein precipitation because I don't know if everyone thinks about this all the time. A lot of labs that I work with, they have kind of a standard protocol for protein precipitation, and it's almost always using methanol. That's because it's cheaper, and you prefer to use your acetonitrile in your LC run, but methanol is a weaker protein precipitator than acetonitrile. So if you're protein precipitating with methanol and then introducing your sample into a column where you're using acetonitrile, you do run the risk of precipitating additional proteins out on the column. So you always want to use a stronger protein precipitator in your sample prep than you are on your analysis. And in this specific example, we're using a very strong protein precipitator called sulfosalicylic acid. It's a fairly strong acid. And we're mixing it with our sample in a 1-to-1 volume ratio. and then we're getting a good protein precipitation, centrifuge, collect the supernatant. And you can see here that since we did a 1-to-1 dilution, that 5% SSA becomes 2.5%. So basically, this is a very simple sample prep. You take your amino acid containing biological sample, you do a 1-to-1 mix with 5% SSA, collect that supernatant, and it's ready to inject directly on the column. So this is a very simple, straightforward, and it works beautifully. I recommend this all the time to my customers. So another thing that's important here is recall that I said this is a mixed mode that's normal phase, Hillock normal phase plus ion exchange. Well, the ion exchange is what's doing the primary separation here. And so because of that, with ion exchange, you want to make sure that all of your amino acids are in the correct charge state to interact well electrostatically with the ion exchange ligands on the column. And by having your sample dissolved in a strong acid solution is going to ensure that we get a good charge, consistent charge across all those analytes, and good interaction with that ion exchange in the column. We'll talk about that a little more here in a bit. I do want to take a closer look at the running conditions. You can see that our A solution is 100% acetonitrile with some formic acid in it. And then our B solution is 80% aqueous. So that's the Hillock portion of this. We're going from low water, or you can think high organic, to high water, low organic. So that's the Hillock portion of this. But as I said, we're also doing ion exchange, and so that aqueous portion of the B solution does contain ammonium formate, where we're increasing the ionic strength of that eluent. And so we're going from low ion strength to high ion strength, and that will act as an eluent for those ion exchange interactions with the analytes. Pretty cool stuff. All right, and so this is just kind of a nice schematic that's showing that, in the adsorption phase, or since these are polar molecules, we have low polarity mobile phase, right? That's going to tend to push that into the stationary phase, so we get a good interaction, we get with the column, and we're going to get good separation. And then when we want to elute, we're going to reverse that. We're going to go to high polarity mobile phases, so high aqueous and high ionic strength. All right. So remember I said that we want to dissolve our sample in an acidic solution. Here's what I'm talking about. Not all amino acids are the same, right? We have some that are basic, some acidic, some that are more neutral. And so if your sample was dissolved in more of a neutral mobile phase, diluent, then what would happen is you might get two versions of those neutral amino acids, right? If it's close to that pi value, as we're seeing in this with pi of 6, then that amino acid could exist in multiple states, and you could end up with multiple peaks. For the acidic amino acid, which has a pi of 3.2, it may not even express much of a charge at all, and so we may not get good retention, or at the very least, we're not going to have consistent retention. The basic amino acid is likely to be in its final state, even in neutral conditions, but that's why I emphasized that the sample should be in an acidic solution, and we prefer something below below like 3.2. So we're below that lowest pi value of the amino acids that you're analyzing. This is one that we troubleshoot quite a lot. So I make a big deal about it just because I feel like if you understand what's happening, it's much easier to troubleshoot down the road and avoid this problem altogether, really. Because a lot of times what people do is they'll dissolve their sample in their starting conditions. And I know a lot of people do that. But if you do that in this case, you're dissolving it in formic acid and acetonitrile, you're not going to get good, consistent results. So we recommend using something like 0.1 normal HCl, or as in the example with the sample prep, this 2.5% SSA solution. Okay, so not only does it not require derivatization, but we get great isomer separation. Here are the leucine isomers. Here are the GABA isomers. You can see nice baseline resolution here. Even with derivatization, these would be very tough. But imagine being able to get this kind of separation even without any derivatization at all. This was a cool project. ADMA, the ratio between ADMA and SDMA could be an early biomarker for cardiac disease. And this column worked beautifully on that separation. So quite a diversified ways that this column is now being used. 10 years it's been out on the market. Here are some tyrosine metabolism pathways. Metabolomic groups absolutely love this column. And what I'm showing here is the comparison between the Intrada Amino Acid on the left, which again is normal phase plus ion exchange mixed mode, and the column on the right, which is a reverse phase plus ion exchange mixed mode. This is one of our other mixed mode products. As I said, we really have all the bases covered for mixed mode needs. So this is just an example of the versatility of the products we have out there. This is just another option. Sometimes you don't want to fully jump into Hillock mode. And here's an example where we're showing you can separate, amino acid-like analytes in reverse phase conditions and still get good results. All right, so just to sum everything up, this is a mixed mode with Hillock plus ion exchange, where the ion exchange is the primary interaction that's going to get the separation. So we imagine that it's probably a very strong negatively charged stationary phase that's able to target the amine groups, that positive areas on these amino acids. So not only does it do great at amino acids, but really anything that contains an amine group. The next thing we talked about was that your sample absolutely needs to be protein free. Pay attention to the strength of the precipitator that you're using. We recommend using strong ones, and we showed that beautiful example. Such a simple, streamlined process of using that 5% SSA in a 1-to-1 mix, and as soon as you collect that supernatant, it's ready to go. And it's in an acidic diluent, which is perfect for getting that strong ion exchange interaction that's consistent and getting good separation. Just stating again, we recommend using it with LCMS since your underivatized amino acids are not chromophores.
Well, I hope you learned a little more about this very cool column and how it might be used in your lab. If you have questions about this column or need any help with any troubleshooting, hit me up. I'm at info@mtacusa.com, and I'd be happy to work with you.